Ignition sequence starts.
Good morning, and welcome to this view of the International Space Station Flight Control Room, where there's always a team of specialists on duty to keep watch over the systems of the space station and help out the Expedition 64 crew members working on science operations and space station upkeep. Commander Sergei Ryzhikov and his American, Russian, and Japanese crewmates have had a full agenda of work inside the station this week, since 3 of them returned from a short trip around the neighborhood in a late-model Soyuz MS almost 1 week ago now.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Sandra Jones. After completing a quick Soyuz relocation trip, the crew is back aboard the International Space Station, completing science investigations and maintenance. On Friday, March 19th, the Expedition 64 crew members who arrived to the space station in October hopped into their Soyuz vehicle, which was docked to the Earth-facing port of the Rosviet module. The crew wasn't preparing to return home to Earth just yet, though. Instead, they were relocating their Soyuz MS-17 vehicle to the space-facing Poisk module in order to make room for the April arrival of another Soyuz vehicle designated MS-18. Russian officials want the Soyuz MS-18 mission to dock with the Rosviet module and not Poisk to allow cosmonauts to use Poisk for a spacewalk later this year to help prepare for the arrival of a new Russian laboratory module. Therefore, a relocation was required. Back on Earth, the crew that will fly to the station aboard the MS-18 vehicle are busy preparing for their upcoming launch. NASA astronaut Mark Vande Hei and Russian cosmonauts Oleg Novitsky and Pyotr Dubrov of the Russian space agency Roscosmos are scheduled to launch Friday, April 9th from the Baikonur Cosmodrome in Kazakhstan. They've been completing final crew trainings at the Yuri Gagarin Cosmonaut Training Center in Russia in preparation for their upcoming spaceflight. 7th through 12th grade students, here's your chance to design an experiment that could fly to station next year. The Genes in Space Challenge is accepting submissions from students to design a DNA experiment that addresses challenges in space travel and deep exploration. Applications are due April 12th, and the winning submission will travel to the Kennedy Space Center in Florida to see their experiment launch to space. And that's Space to Ground for this week. Thanks for watching. We'll see you next week.
Sandra mentioned this year's Genes in Space Challenge and that submissions from junior high and high school students are due in about 2 weeks. For those of you interested, wondering what that looks like, join me now for a trip back in time 6 years to when Anna Sofia Bogorayev designed the winning experiment that flew to the space station.
When I was 4, I told my mother I was going to be an astronaut, so it's kind of been a perpetual thing from there. And I figure if I'm going to be an astronaut, I don't want to be getting sick. And if someone isn't doing what I think about the immune system, why don't I go look at it myself? This is the mini PCR machine designed by Mini PCR. PCR is polymerase chain reaction, so DNA amplification. We now have more DNA amplification capabilities on the station, but when this went up, it was the first.
Hi, this is Tim Peake on board the International Space Station, and this is a message to Anna Sofia to say huge congratulations for your winning submission to investigate the effects of cosmic radiation and microgravity on the body's immune system.
So you're meant to have a balanced ratio of your T helper 1 and T helper 2 cells, but when you're in space, you get a much more dominant T helper 2 phenotype, which decreases your cell-mediated immunity and just generally hampers your immune system.
While we're on the subject of student support of the International Space Station, here's a look back at some students from the Houston area who designed and built a tool that was used in space during the 2019 spacewalks to restore operation of the Alpha Magnetic Spectrometer. It's another example of how the Artemis generation is contributing to NASA's mission right now. One priority of the International Space Station's science research program is to learn as much as possible about how living in space affects the human body. Now, shortly before she came home 2 years ago, astronaut Anne McLean and her crewmates finished with all the data gathering on the airway monitoring experiment, which examines an astronaut's exhaled breath for signs of inflammation, creating data that can be used in the development and design of new spaceships.
The International Space Station is a national orbiting laboratory. Every single day we are answering big questions about Earth and about space, about where we came from and about where we're going. One category of those experiments are human research, experiments on our human body, how we react in microgravity. One of the recent ones that I've been a part of is called airway monitoring, and this is looking at airway inflammation up in space. So when we're breathing the air, you know, the small particles in the air, they don't just fall to the ground like dust on the ground. So we tend to inhale more fine particles than we would on Earth. And so we're looking at our response, our body's response to that by measuring nitric oxide exhalations as an indicator for airway inflammation. And so understanding, you know, how clean does our air need to be? How does our body react to the air? When we talk about going back to the moon, you know, a lot of people are aware that the moon dust is a very, very fine particle. It's almost like a powdered sugar fine particle. And if that's in the air and we're breathing that for months on end, if we're doing, you know, extended stays on the lunar surface, you know, we need to understand kind of how that affects the human body.
In more than 20 years of continuous human presence on the International Space Station, more than 3,000 science experiments have been conducted. Just last year, that included everything from growing radishes in microgravity to capturing 360-degree video footage of life on the station. Have a look at some of the highlights of recent research that's benefiting people on Earth while helping prepare us to explore farther into space. The laboratories of the International Space Station aren't the only places on the vehicle where scientific research takes place. The outside of the station is home to a number of experiments, including the Total and Spectral Solar Irradiance Sensor, which is continuing NASA's work of gathering data to help researchers investigating changes to Earth's climate.
Follow the Sun. Presented by Science at NASA. The sun. It inspires songs, warms us, and grows our food. Life on land and in the oceans, the daily weather, and long-term climate patterns happen primarily because of the energy we receive from our closest star. Even tiny variations in that energy can affect the workings of our planet's atmosphere. NASA uses instruments to follow the sun and monitor the amount of solar energy coming to us. The latest instrument to do so, the Total and Spectral Solar Irradiance Sensor, TSIS-1, makes those measurements with unprecedented accuracy. TSIS gathers information from its perch aboard the International Space Station, or the ISS. Flying on the platform that the orbiting laboratory provides has allowed TSIS to continue NASA's 40-year record of tracking the sun's radiant energy, one of the longest and most important climate data records gathered from space. Over the past several decades, Earth's ice mass has diminished, sea levels have risen, drought and precipitation patterns have changed, and growing seasons have shifted. To understand the causes, including human influences, of these changes, and to refine the models used to simulate Earth's climate, researchers must know the amount of incoming solar energy. Peter Paluski, TSIS lead mission scientist, explains, when there's a balance between incoming energy from the sun and the infrared radiation Earth emits, climate remains steady. An imbalance means energy is either being stored in the system, causing temperature increases, or lost, causing temperature decreases. Energy from the sun makes up half of the balance equation. Even though the measurement record shows that the sun's solar energy output has not had a major influence in recent climate change, that output needs to be monitored continuously. It is arguably the most important variable we need to know to understand climate, says Paluski. Trying to understand climate without measuring the sun's input is like trying to balance your checkbook without knowing your income. Climate is measured over long time spans, decades to centuries and longer, unlike weather that changes over small time scales. To be able to connect measurements over long time periods, continuity and accuracy are key. TSIS has two sensors. The Total Irradiance Monitor, as its name suggests, measures all of the radiant energy from the sun, and the Spectral Irradiance Monitor measures how that energy is distributed over ultraviolet, visible, and infrared wavelengths. The latter helps scientists understand where in the atmosphere solar energy is being absorbed. For example, TSIS spectral irradiance measurements of the sun's ultraviolet radiation are critical to understanding the ozone layer. Ozone in the stratosphere absorbs ultraviolet light. This heats the stratosphere and drives changes in atmospheric wind flow that can propagate down to the lower atmosphere and impact climate. So many factors influence Earth's climate, says Paluski. We need to continue learning how they all interact. TSIS is helping us characterize the sun's behavior and how Earth's atmosphere responds to the sun. For more science from the International Space Station, go to www.nasa.gov/ISS-science. To continue following our closest star, visit science.nasa.gov.
Along with assisting with experiments in microgravity and the occasional robotic arm operations or spacewalks and the ubiquitous other duties as assigned, astronauts on the International Space Station devote some of their time to help students who are studying science, technology, engineering, and math. In this demonstration video, astronaut Ricky Arnold shows us how the molecules that make up water behave in space.
Welcome to the International Space Station. I'm NASA astronaut Ricky Arnold. Our view from the ISS of Earth is absolutely magnificent. but we quickly realized we really should call it Planet Ocean. We are mostly a water planet. Water occurs here in all three phases, solid, liquid, and gas. And the presence of water on other planets and moons within our own solar system has us wondering, is there life there too? Well, why is water so special? One reason is called surface tension. So what is surface tension? Let's have a look. Surface tension is a property of liquids in which molecules of one substance are more attracted to each other than to molecules of another substance. Water is unique in that it has a high surface tension compared to other liquids. This is due to its polar property. The positive hydrogen ends and the negative oxygen ends create a strong bond. As they say, opposites attract. So the hydrogen end of the water tends to stick to the oxygen end in a nearby water molecule. At water's surface, its molecules are only attracted to the water molecules below and to the sides of them, as there is only air above these molecules. So the surface molecules of a body of water are pulled down, creating a more stable, stronger environment. That is why certain animals, like the water strider, can actually walk on the surface of water. Here on the International Space Station, the microgravity environment makes it easy to show how well water uses surface tension to stick together. We even rely on surface tension to help us wash our hair, those of us that have a lot. Thanks for coming along today and learning a little bit about surface tension. Want to learn more about the unique properties of water and do your own experiments? Try out the activity related to this video at the STEMonstrations website. See you next time.
There have been 64 expeditions on the International Space Station since the year 2000, with more to come. And all of them have worked to achieve scientific goals while getting humankind ready for the next step in space exploration. That is, moving out beyond low Earth orbit to return to the Moon in just a few years and then out into the solar system to Mars. NASA is building the systems right now that will take us to our next destination.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the Moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The Moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the Moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the Moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going.
We're going.
An expedition on board the International Space Station doesn't just lead to advances in science. In some cases, it can cause changes to the scientists who work there. NASA astronaut Jessica Meir says being in space was even better than the dream she had as a little girl about being an astronaut, and that the feeling of looking down on the whole world of her previous experience took time to process.
In first grade, when we were asked to draw a picture of what we wanted to be when we grew up, and I remember drawing a picture of an astronaut standing on the surface of the moon, the kind of iconic Apollo image in the spacesuit next to the flag on the moon. And that was what I drew then and said I wanted to be an astronaut, and then always said it all the way through since that time. I knew that I was going to be ecstatic being in space. You know, it was my lifelong dream, and I knew that it was going to make me happy. But I didn't expect how incredible it felt. And I said that a lot to people, that it's even more incredible than I ever imagined. And I really meant it, because I had thought so much about it, and I knew it was going to be the most extraordinary experience of my life. But I wasn't even prepared for how I felt, the level of excitement and just pure joy that I felt all the time in that environment. I really felt like I was home. I felt like that was where I should be, and I don't think I stopped smiling for pretty much the entire 7 months. I would find myself thinking, how can this be real, that I'm floating above the planet and looking down on it? You know, even after 7 months and, you know, knowing what we had done to get there and that I'd really worked for this my entire life, it still is actually hard to convince yourself that it's really happening, which maybe sounds a bit funny, but even after 7 months, it just felt that way looking down on the Earth. Wow, this is real. I'm up here floating above the Earth. When you're in the space station in the cupola, there are stars all around you, and you can really feel it that way. I think that's a good way to describe it. You feel like it's more three-dimensional and diffuse, and you know, you gaze off into it, and it is really just extraordinary to think about that scale, and then look back at the Earth and realize that we're just such a small component of that. This was really what had driven me since I was 5 years old, was what it was going to be like to have that feeling, to look back on the planet and you're not there. That's the place, the one place where everything has happened in your life, everything has happened through the entire history of the human species. Everything you've done, all the places you've been, everything is down there in its entirety, and you're separate from that. It actually does feel different looking at Earth through your visor, just through your helmet visor, versus looking out of the window. I think the colors are even more vibrant, And I think also just mentally, psychologically realizing that, there's nothing between the vacuum of space except for this spacesuit and your visor. There's nothing, between you and it. And you're really out there in your own little mini spacecraft. It has the life support system, everything that you need to be kept alive, and it's just you. And you have this sense of just being by yourself in this environment with your own little life support system. And I love that feeling. I don't know what it is exactly about that, but I feel really kind of peaceful and relaxed in that. And in the spacesuit, you're looking down and seeing the Earth from above, from the outside, with your own human eyes. It changes you as a person. When you look back and you're in this blackness, devoid of any color, the blackness of space, and suddenly there's this brilliant blue glowing marble down there. It's so easy to see from up there that we're all in it together. You don't see those geopolitical boundaries, all of the man-made boundaries that we've imposed upon ourselves as humans. You don't see any of that from space, and you just feel this sense of commonality more, and something that unites us all, and just that we're all human.
If you want another look at any of the stories we showed you today, you can always find them on YouTube and Facebook, where you'll also find lots of other great features on a variety of NASA topics. Be sure to look around. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show talking to folks involved in all areas of space exploration. Today, Gary Jordan gets into the pros and cons of a spaceship feature we don't yet have. This is his talk with former head of NASA's Human Research Program, Dr. Bill Pulaski, a leading expert on the subject of artificial gravity. Go to nasa.gov/podcasts for this week's episode and all the previous episodes, and the full library of all NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.